Hi students, last class we discussed about Gauss law and some important points regarding Gauss law, and we have started doing numericals and Gauss law. So we will continue from there, right? So for example, if you are having a cube like this, imagine like this, right? At the center of the cube there is charge Q. Then now imagine a sphere. At the center of the sphere imagine a charge Q. So my question is, find the flux through the cube and find the flux through the sphere, right? So according to Gauss law, if you want to find out flux, we need a closed surface, right? And according to that law, flux through any closed surface is equal to charge enclosed divided by epsilon naught. So what's the flux through the cube here? So flux through the cube is equal to Q divided by epsilon naught. And here there is a sphere. So what is the flux through the sphere? That is also equal to Q by epsilon naught. Now, the flux through the sphere, the flux through the cube, both of them are equal. That means the flux is independent of shape of the surface, but depends only on charge inside the closed surface. So we can have one point here, that is flux through any closed surface. Flux through any closed surface, right, is independent of surface, but depends only on charge inside the surface. Charge inside the surface. And this point we have discussed in the last class, right? Now see carefully. So for example, you are having a cube now, right? The charge is exactly at the center of the cube. The charge is exactly at center of the cube. So here center of the sphere, and here center of the cube, right? Here at the center of cube. Now the charge is displaced slightly. The charge is displaced from here to here. Displaced little bit. My question is, so what is the flux through this cube and what is the flux through this cube? Right? In both cases, flux is same or flux is not same. So according to Gauss law, flux through any closed surface is equal to charge enclosed divided by epsilon. So flux through the cube is equal to Q by epsilon. In this case also, flux through the cube is also equal to Q by epsilon. So from these two, what can we say? Right? Flux through any closed surface is independent of position of charge. Independent of what? Position of charge. But on what factor? It depends only on charge inside the surface. But it depends only on, so charge inside the surface. So charge inside the surface. Is that clear? Right. So we can say that the flux through any closed surface is independent of shape of the surface, is independent of position of the surface, but depends only on charge inside the surface. Right? Then, so for example, let us take a cube like this. A charge is exactly at the center. So find the flux through the cube and find the flux through any one face of the cube. Find the flux through the cube and find the flux through any one face of the cube. Is that clear? So, according to Gauss law, we know very well, flux through any closed surface is equal to charge enclosed divided by epsilon. Let me take this positive charge. So, electric field lines pass through the surface like this. Right? So electric field lines will pass through the surface like this. Right? That means the charge is identical to all the 6 faces. That means through each phase, flux is same. Right? So I can write 6 times flux through each phase is equal to Q by epsilon. Then what is the flux through each phase? Flux through each phase will be equal to what? Q by 6 epsilon. So flux through one cube is equal to Q by epsilon, and the cube contains 6 identical faces, and the charge is symmetrical to all the faces. The flux through each phase will be same. So I can write 6 times the flux through one phase is equal to Q by epsilon. Then what is the flux through one phase? Q by 6 epsilon. Is that clear? Right. Then, so for example, once again let us take a cube and a charge is placed at the center of one center of one face. The charge is placed at the center of one face. My question is, so find the flux through the cube. Right? Now, you want to find out flux. We need a closed surface. Right? But the charge is on the surface. So the surface is not closed. The charge is not inside the closed surface. That means we need to imagine a Gaussian surface. I told you, Gaussian surface, it is always better to imagine symmetrical surface. Then, what type of symmetrical surface you can imagine? Right? So, if this is the cube, right? And here there is a charged cube. Then imagine another cube like this. Imagine another cube like this. You imagine another cube. So the charge is in, see, and we are imagining an identical surface like this. So the charger is exactly between two identical cubes. The charge is inside the closed surface. So flux through two cubes is equal to Q by epsilon. Right? So I think if it is positive charge, so electric field lines will go through both the cubes like this. Will you agree with that? So lines will go this way. So flux through two cubes is equal to Q by epsilon. Flux through this cube is also equal to flux through this cube because the charge is symmetrical to both the cubes. So 2 times flux through each cube is equal to q by epsilon naught. Then flux through any one cube is equal to q by 2 epsilon. Right? Then, now if I give a question like this, there is a cube, right? And here there is a charge which is placed at the center of one face of the cube. Then, the flux through this face is phi. Find the flux through this face. Phi 1 is equal to how much? So there is a cube and there is one charge which is at the center of one face of the cube. The flux through this face is phi. Find the flux through this face. Right. Now you want to find out flux. We need to apply Gauss law. If we need to apply Gauss law, we need an imaginary closed surface or we need a Gaussian surface. I told you, it's always better to imagine a symmetrical Gaussian surface. Now can you guess, so what type of symmetrical surface you can imagine? Right? So what type of symmetrical surface you can imagine? Now see carefully, it's very simple. Now this is the cube we are having right now. Right? And the charge is here. The charge is not inside the closed surface. I told you, the surface may be imaginary. It may not be real always, right? So imagine another identical cubical surface. Right? Imagine another identical cubical surface. Is that clear? No. The charge is identical to both the cubes. Will you agree with that? So this face is identical to this face. Will you agree with that? Then flux through this face is phi. Then flux through this face is also phi. Then flux through this face is phi 1. Flux through this face is also phi 1. And you see here, if this is the cube you are having, this is one face, right? This is back face, right? This is front face, right? This is a bottom face. This is front face, this is back face, this is top face, this is bottom face. See, for this one, for this one, for this one, for this one, the charge is identical. So the charge is identical, the charge is identical, the charge is identical, the charge is identical. So this charge is identical to all the four faces. That means flux through this face, flux through the bottom face, flux through the front face, flux through the back face, and here also flux through the bottom face, flux through the front face, flux through the back face is identical. And these two faces are identical to this charge. Then, so according to Gauss law, flux linked with any closed surface is equal to q by epsilon naught. That means, so we have 8 times phi 1 plus 2 times phi is equal to charge enclosed divided by epsilon naught. Right? Then 8 times phi 1 is equal to q by epsilon naught minus 2 phi. So phi 1 is equal to, so q by 8 epsilon naught minus 2 phi by 8. That means phi 1 will be equal to, so q by 8 epsilon naught minus phi by 4. Is that clear? So the charge is identical to these two faces. So flux through this face and flux through this face is 5, 5. And this charge is identical to all these 4 faces and all these 4 faces. So 5 1 5 1 5 1 5 1 5 1 5 1 5 1 backside 5 1 5 1. So 8 5 1 plus 2 5 is equal to q by epsilon naught. So 5 1 is equal to q by 8 epsilon naught minus 5 by 4. Please try to imagine this idea or try to imagine this diagram. I hope you have understood. Right? Then now if you are having like this, there is one cube like this, right? A charge is present at the center of one edge of the cube. At the center of one edge of the cube. My question is, so find out the flux through this cube. Find out the flux through this cube. Now, if you want to apply Gauss law, we need a Gaussian surface. The Gaussian surface, it might be imaginary or it might be real, that we don't know. Right? Now, I told you, it's always better to imagine a symmetrical Gaussian surface. Then, how can we imagine a Gaussian surface such that it is symmetrical, such that the charge is inside the closed surface? Right? Can we imagine like this? Try to think a little bit. Imagine here, this is where your imagination is required for us. Excuse me. Now see how I am drawing it. I hope you are able to understand. Right? One minute. So let me imagine a cube. In fact, it's not a cube. Check carefully. Yeah, now we got it. Right? A rectangular, maybe a rectangular box. Now what I do? Imagine total 4 cubes. 1 minute. Right? Excuse me, 1 minute. So we are having one cube like this. On top of this, imagine another cube. So something like this. Yeah. So where is the charge now? Let me. Where is the charge? Where is the charge? Here. You see here, one cube here, another cube here. 2 cubes are. But the charge is still open. So what I do? On the back side, I can imagine one more cube. So on the back side, I can imagine one more cube like this. It's a little bit difficult to draw it. On the back side, I can imagine one more cube like this. Right? On the back side, I can imagine, so one more cube like this. It's a little bit difficult to draw it. Yeah. Is that clear? Or how can you draw? We draw one rectangular box like this. You draw one rectangular box. Right? Something like this. Then, in the middle, you draw one more line like this. Yeah? And then you draw one more line like this. Right? And then you draw one more line like this. Now the charges. Now you got it. Now you got it. Right? So, here there is one charge Q which is at the center of the H. So, I can imagine another 3 Qs such that the charge is exactly inside the 4 cubes. So this is the actual cube. We are imagining here behind that one more cube, and this is the actual cube behind this one more cube. Is that clear? Total how many cubes are there? 4 cubes. Now the charge is identical to all the 4 cubes. If the charge is identical to all the 4 cubes, then flux through 4 cubes is equal to Q by epsilon. That means 4 times flux through each cube is equal to Q by epsilon. Then the flux through each cube is equal to Q by 4 epsilon. Is that clear? Is that clear? I just explain the diagram once again. So what you do, you just draw a rectangle, right? You draw here another rectangle. You join these two, join these two, join these two, join these two. My diagram may not be exactly correct, but picture of that you can understand. Then what you do? You draw another line like this, right? You draw another line like this, right? You join them like this. So roughly, I think we can have a total 4 cubes, and the charge is exactly here. Right? So flux through 4 cubes is equal to how much now? Q by epsilon. So 4 times the flux through each cube is equal to